Hey, welcome to this video. In here we're going to do a note cards review for the concepts that is really easy to get ignored or to misconceptualize with other topics. So in here we're just going to do a quick, briefly re-emphasize of those concepts. Let's jump right in. First is the squeeze theorem. This is also called a sandwich theorem if it helps you to remember. What it actually said is, suppose the limit as x approaching c of h of x is equal to L and limit of x approaching c of g of x is equal to L. So both of these limit functions are approaching the same number. And if f of x is in between the closed interval of h of x and g of x, then we can say that the limit of x approaching c of f of x is in between the closed interval of limit of x approaching c of h of x and limit as x approaching c of g of x. And because the limit of x approaching c for h of x and g of x are both the same number, which is L in this case, we can say that ultimately limit as x approaching c of f of x is equal to L. So you can see kind of we're kind of squeeze the formulas and the inequalities together like step by step, and ultimately we just get a exact number as our answer. So that's the reason that I call it squeeze theorem. And also let's take a look at the magnitude of functions. This is a really important concept. It helps you to quickly do some multiple choice questions instead of writing out the process and steps to find the exact number of that function. So what does it really look like? Well, we're going from the slowest rate to the fastest rate. First is the logs, then is the polynomials. Radicals also puts in here. Then is the exponentials, factorials, and last but not least, f of x raised to g of x. This is really saying a function raised to another function. So whenever you see a function that is growing that is growing faster in the denominator, the whole function will approaching zero. If the numerator growing faster, then the whole function will go into infinity. Then let's talk about related rates. So related rates, I recommend you looking at the notes and examples for studying. So whatever your teacher or professor gives you, that kind of stuff, feel free to check it by yourself because there's a lot go into it. The only recommendation or some little hint I would say is do remember the formulas for the volumes of like some common ones, and be able to take the derivatives on both sides for that formula, and then you plug the values back in and then you solve, and ultimately you get the answer. It's not that difficult, but definitely needs practicing. Then let's take a look at this example. Write f of x is equal to 1 over 2x minus 1 as a power series centered at x equal to 2. So how can we do that? Well, we are given the f of x. We want to write it in a power series that has centered at x equal to 2. So what we're going to do first is put a parenthesis around x and plug a negative 2 in, represent x equal to 2. Because when x equal to 2, the denominator becomes 0, then the whole function just becomes indefinite on that point. But we cannot just randomly put a negative 2 inside the parentheses of x. We should do some subtractions or additions to counter that effect. So what I'm saying is, take a look at here, because originally we only have 2x, but right here we have 2x minus 4. We have a minus 4 that appeared from random, so we have to plus a 4 to counter that effect. Therefore, the whole denominator just becomes 2 times x minus 2 plus 3. And rearrange that to make it more easier to do the next part, we will get 1 over 3 plus 2 times x minus 2. And remember the format of power series, we want to put the 3 in front. So we will divide every terms inside by 3, which is 3 times 1 plus 2 over 3 times x minus 2 parentheses. Therefore, we can rearrange that more to 1 over 3 over 1 minus negative 2 over 3 times x minus 2. Therefore, we will get A as our answer, which is 1 over 3, and R is equal to negative 2 over 3 times x minus 2. We can plug that into the formation of the power series, which is the summation notation of n equal to 0 going to infinity, a times the r to the nth power. And r in here is an ugly function, but it's okay. As long as we write it in this format, we're fine. And then we can do some more simplifications now. To put it into a more simpler way, we can write it as negative 1 raised to the nth power times 2 to the nth power times x minus 2 to the nth power. And then we put the denominator as 3 to the n plus 1 power. And that's it for our final answer, the power series that is centered at x equal to 2. And that's all for this video. Thank you so much for watching. And again, this video just kind of gives you more ideas about some little tiny details that people are really easy to get ignored, or maybe it'll help you on the exam, I don't know. But thank you so much for watching. Hope you have a great day.